of buoyancy. Next tayo, how about yung moving vessel? So we have here a container with fluid inside. Na? So dito, meron tayong 3 meters wide, 4 meters long, 2.5 meters deep na container which contains 2 meters deep of water. So accelerate siya to the right. Ngayon, hanapin daw natin yung slope ng water surface. Calculate the acceleration before the water will spill out. And at this rate, what is the force causing the acceleration of the mass? Causing the acceleration nito if the mass of the vessel or the container is 500 kilograms. So, let's try to solve one by one. Una, yung slope ng ating water surface. Okay, so before, we've seen the formula for all of this. It's just tangent theta is equal to the acceleration or horizontal acceleration of the container divided by the gravitational acceleration. So here we can now get the angle theta for the slope of the water. Okay, so the acceleration now before spilling. Considering guys na before spilling, ito kinukuha natin yung theta before it's going to spill out bago may matapon na tubig. So in this case, it's the angle 18.43 bago may matapon. And now, after getting the theta, we can, actually yung theta na pinagkuha natin is by geometrical. Okay? By geometry. Kasi alam natin that the shifting of this is on the center. Okay, laging sa center yan, guys. Basta wala pang natatapon. Okay, take note of that one. This surface or the water surface will shift based on the center. Kalahati ni 3 meters. And basta, no, unless wala pang natatapon. Now, if water is being spilled out, the center of this slope will never be on the center anymore. Or yung half netong ganito, distance na to. Pag may natapon na, the reference will never be on the center anymore. So hanggat wala pang natatapon, yung center natin ang reference ng pag-rotate netong water surface. Okay, so using geometry, we can solve for the angle theta maximum before something spills out. So we know the information about the container and the depth of the water, so we can get this triangle. Ito. Kasi diba, 2.5 yung depth ng ating container while the water itself is in 2 meters. So we can now get the angle here by getting the additional space for the water and the half of the base distance. So then, we can now get the angle. Then after that, use that angle in order for us to get the acceleration to go there, to go in that situation. So here, tangent of the theta is equal to the acceleration over the gravitational acceleration. Now we can get the horizontal acceleration as 3.27 meters per second squared. The next after this, let's calculate the force, which will, if the mass of this container is 500 kilograms. Now we can use this acceleration at the same time, this mass, for us to get the force. So just multiply both of them. We can now get that the force needed for it to happen would be 1,635 newtons. No, it's that easy. Now, what if there's something that will be spilled? Like, for example, the acceleration, same container, same amount of water, but now the acceleration would be 6 meters. Okay? The maximum acceleration before you can spill something out with that container would be 3.27. But in this case, it would be 6 meters per second squared, which means that we already know that this container or this water inside the container will spill out due to the addition of acceleration based from what we saw before. Okay, so if it accelerates, this is not on the center of 3 meters anymore. Okay, so the first thing we need to do is to look whether what case are we going to be solving. So if you remember before, the case 1 would just be before spilling. Case 2, it was already spilled, but the other water surface is just before it goes to this corner. The case 3 would be this water surface on the right side would be at the corner, and then the case 4 would be after the corner. So let's find out later on. So we have the acceleration or the horizontal acceleration now. We can get the angle theta. So let's see. 6 over 9.81, get the arc tangent of that. Then we will have our angle theta as 31.45. Now, with this angle, can we check if it's case 2, case 3, or case 4? Yes. Why? We can conclude that if it's in case 3, then we know the total height and the total base for the angle at the corner, right? So use that information. For this angle, from this point up until the corner at the rightmost bottom, would have a height of 2.5 and the base of 3 meters. Now get the inverse tangent of this one. We can get that the angle theta would be 39.81, which is larger than the actual theta that this water surface is showing. And in this case, we can now conclude that it's under case 2 because it never went to the corner, just before the corner, because this is smaller than the angle for the corner. Okay, now that we have that information, we can now solve for some missing values here, like the height, because we should know the volume. The question was, the volume that was spilled out, how much is it? Now let's try to find out this height, knowing that we have an angle and we have the base of this triangle as 3 meters. This will never change. Now the height of this slope would be multiplying 3 meters with tangent 31.45 degrees. We have now the height as 1.83. Okay? Now that you know the dimensions of this trapezoid and the initial water surface, that is the horizontal one when it's not moving, we can now get the volume that was spilled. So the volume originally was the rectangular shaped one, right? So it would be the case where it's in equilibrium before you even apply a horizontal acceleration. And the V that was left would be on this case when after acceleration has occurred. So the original volume would just be the volume of a rectangle. So guys, this one would be just the area. I only included area here because of space issues. I multiplied the 4 meters just after having this one. Due to space issues, sabi ko nga, hindi siya kasha, no? So, I just decided to multiply the length, 4 meters here, after getting the area here. Okay, so get the area first. That would be the area of rectangle. That's 3 meters of base times 2 meters of height minus the left volume. How much is left? So I decided to cut this down, or this trapezoid down, into a triangle and a rectangle. Or you can just go for the area of area of trapezoid. It's up to you. Dali lang din naman ang area ng trapezoid. Okay, so now we can get the area, in this case, 1.245 cubic meters. Multiplying it with the lapad, or the width or length, it doesn't matter, times 4, then the volume that was spilled was nearly 5 cubic meters, or specifically it's 4.98 cubic meters. So that's the process of solving these problems. And then find out if the water will be spilled or not. Then if it really spilled, check out if it's under case 2, 3, or 4. So in this case, your ability on doing solid mensuration and even geometry would be put to test. Even trigonometry. So here is the explanation regarding the water running out. If it's case 3. So check whether this would happen or not by getting the angle. So here, another problem, the tank shown in the figure contains oil. Now it's oil, 0.88 in specific gravity. If the tank is 10 meters long, the initial depth of the soil is 2 meters, and the tank accelerates to the right at 2.45. Assume the tank walls are sufficiently high so that there's no spillage. Okay? So here, let's just get first the slope of the water surface. Now, with this angle, or with this acceleration, let's check what the theta is. So the theta is 14.02. Okay, let's check whether this will have a spillage or not. Wait. No total height is given, right? So I think no spillage would occur. Why? If there's no such information about the total height of the container, then how can we assume that the water would go out or flow out of this container while it moves, right? So in this case, I think no water is spilled. But some important announcement for some of you. For board exam questions, there are instances where problems aren't really complete and yet you need to solve them. I think you need to do some reverse solutions to do that and think on how the examiner tried to do the problem. You can't do anything otherwise. You can't even complain to the one in front who manages everything for the board exam. He doesn't know anything about it. Okay, so in this case, let's try to solve for this. Knowing that no water will be spilled, we have theta 14.02. So the maximum pressure at the bottom of the tank would be based in the pressure here on the left and on the right. Because if water has been, or the water surface has been shifted, then of course the pressure for each and every corners that we have would be different. In this case, it would be of higher water surface, and on the right side, it would be on the lower one. So we can compute the pressure speech. Now, first compute the height with which we can now first compute the height with which the water surface have shifted with the use of this angle, knowing that if nothing was spilled, then it's on the center as the basis of rotation. So height 1 would be tangent 14.02 equal to the opposite over the adjacent. Now we can get the height 1. So the height that was increased here would be also the same amount of the height that was decreased here if it is on the center as the reference. So we can now compute the pressures of each on the left and right as gamma h. So that would be gamma 0.88 since it's oil times the gamma of water 9.81 and the height at the left side. So the pressure at the left side is 28.06 kilopascals. The minimum pressure would be at the right side, reducing the height to 1.25 meters, and now the pressure at the right is lesser, 6.47 kilopascals. Such information is needed because when you try to design the container, it should be able to try and resist these pressures when it moves. If not, then the water pressure or any fluid pressure inside the container would destroy your container if it's not properly designed. So another problem, an open rectangular tank 3 meters long, 2 meters wide, and 1.25 meters deep is completely filled with water. In this case, if a container is completely filled with water and you move it on a horizontal basis of acceleration, of course, water will be spilled out, even just a tiniest acceleration you can find. Okay, so if the tank is moved with an acceleration of 1.5 meters per second squared, find the slope of the free surface of water and the quantity of water which will spill out of the tank. So this is just going to be easy since the water is fully filled inside. Wait lang. Wait lang, may message si Sir Vega. Okay. It was about the admitted status of some students. So, sana wala nang admitted status sa inyo. I can't really see because I'm not sure why the subject is not yet on my portal. But I can't wait, that long. If it's going to be transferred to me, I need to have a discussion already, and of course try to make some assessments already. Okay, so let's try to solve this one. Slope of the water surface theta, we have here acceleration over gravity, gravitational acceleration also. So here we can get that the theta is 8.69 degrees. It's just that easy. Then the volume of water spilled is also easy because it was completely filled before. Now that it moves, some parts will be gone. And of course, it would be easier for us to get the volume that was gone based on this situation because you cannot really try to go for the total volume inside or compute the total volume minus the volume that was lost. But rather, we can now try to solve the volume just by getting the volume of air inside this container due to it being filled before, right? So in this case, the volume of the spilled water would just be the area that was lost here times the thickness. So 3 meters would be this one. And then the angle theta that was solved before, you can use tangent theta again. And now, getting the height, it would be 0.459 meters. And get the volume, it would be 1/2 times the height times 3 meters. But wait, no. Okay. I should have multiplied 2.5, right? Yep. I should have multiplied 2.5 here for us to get the final answer. I thought it was a 1 meter strip. So that is 0.459 times 1/2 times 3 times 2.5. The volume should be 1.72 cubic meters. I forgot to add the 2.5 meters. Okay, so here, for flow rate, water flows in a 40 mm diameter pipe at a velocity of 0.5 meters per second. So determine the volumetric mass and weight flow rate. First, the volumetric flow rate. It's just easy. It would be the volume over time. But we can get another equation for this one. Would be the area times velocity. Now, the cross-sectional area for this one is a circular shape of cross-section. So it's pi d squared over 4 as the area. And the velocity is given as 0.5. Now we can get the QV or the Q or the volumetric flow rate as 6.2832 times 10 raised to negative 4 cubic meters. But if we are to convert this into liters, take note guys, 1 cubic meter is 1,000 liters. So if you have a 1 meter by 1 meter by 1 meter container, you can fill it up by 1,000 liters of Coke. Okay, so ulitin ko, 1 cubic meter is equal to 1,000 liters. Kaya, ayan, times 1,000 can be this situation. Now, mass flow rate, we can just try to multiply rho with the QV. And the rho we'll try to take for would be in kilograms per cubic meter. So in this case, we can now get the volumetric, the mass flow rate as 0.6283 kilograms per second. So it's in kilograms, no mass flow rate. In weight flow rate, you can just multiply here 9.81 meters per second squared to become a Newton, or 9,810 for a Newton basis na in the volumetric naman. So nasa sa inyo yan, you can go for mass flow rate because mass is just, di ba, weight over the gravity or the acceleration due to gravity. You can use mass flow rate or volumetric flow rate to get the weight flow rate. Doesn't matter, it will yield the same answer. So in this case, you can now get the weight flow rate as 6.1638. newtons per second. So it's just that easy. This is just preparatory topic for our Bernoulli's equation later on. So that would be your week 4 and last topic. I think for the prelim, it would be Bernoulli's equation, and your quiz for that would be, I think, before or after. We'll see, because of the tentative schedule of the exam. I think it's March 10, if I was correct. So let's see. And that's all for the examples we have for the week 3. So to sum everything, we had dam, we had Archimedes' principle of buoyancy, we have the accelerating fluid, and the last one would be the flow rate. Okay, so next time when you try to review, try to think up of all the topics that might be going out depending on the time limit that will be given to you. Exam, I don't know who will do it, but I have prepared one for me. I'll let Daryl see the exam I did, but I think Daryl wanted to have a multiple choice exam rather than having a problem solving. You know me as a teacher, in the still design, no, I don't really go for multiple choice problems, but it's possible. We'll see. I'll try to discuss with Daryl and see what would happen for this. So prepare for your quiz now in the LMS, and later 10:30, I think you will be excusing your classes because of the CFET thing. And yeah, that's all for today, I guess. You can now go and prepare then.
Sir, dun sa quiz, sir, pwedeng sa PM, sa Messenger din, sir?
Yeah, no problem. Go for Messenger messages. It's
Sige po,
easy
sir.
for me
Thank
to
you.
collect here. So it's 9:30 to 10:30, no, yung quiz niyo.